In kinematics, we have studied about linear momentum. Just revise that point once. From that, let us understand what is angular momentum and all the conditions to calculate it. So, linear momentum of any mass m, which is traveling with velocity v, is given by mass times velocity m. When a body is traveling along a line, the momentum associated with that body we will call as linear momentum. Now, what does this angular momentum means? How can we explain the angular momentum? Very simple. Let us consider a situation like this: x and y axis, like xy plane. Now, an object of mass m is traveling with a velocity v, is being observed from origin. Listen carefully. Is being observed from origin. Observer is at origin. Now, with respect to this observer, the position of this mass will be keep on changing in such a way that it looks like traveling in a circular path, or it is in rotational motion. The basic definition of rotational motion, if you remember, if the angular position of an object is keep on changing with respect to any reference line, I mean theta is changing with respect to any reference line, that we will call as rotational motion, right? So when the object here, it was here, let's say angle was theta 1. When the object is moving and somewhere here it has come, let's say angle is theta 2, which means theta has changed, where theta 1 is not equals to theta 2, which means that to this observer, it appears like moving in a rotational motion, like being in a rotational motion. That means to this observer, the momentum of this object, which is mv, appears like changing with respect to position, changing with respect to angle. That means to him it looks like as a rotational momentum, which means angular momentum. So angular momentum basic definition we can say technically, not mathematically. It is the moment of the momentum. Moment of the momentum means rotational effect of the momentum. As we know that moment of force is torque, like rotational effect of force. Like that, moment of linear momentum is said to be angular momentum. Okay, so now I can say statement as to the observer, to the observer, the motion of object looks like a rotation. So this linear momentum with respect to the observer will be angular momentum. Angular. Okay. So simply another name what I said, moment of momentum. I mean rotational effect of linear momentum. Another name what I said, it is moment of momentum. This is what technical definition. Okay. Mathematically, how to express this? What is the expression of this angular momentum mathematically? Mathematically, mathematically, angular momentum is given by L vector is equals to, remember, R vector cross P vector. Very important expression. What is it? It is the cross product of position vector and linear momentum vector. You take the cross product, it will be R vector cross P vector. So we can write this like L vector is equals to R into P into sine theta, cross product of two vectors, into n cap. Or we can also write L is equals to R into P is nothing but mass into velocity only, no linear momentum, into sine theta, the magnitude part, into n cap. So mathematically, the expression of angular momentum is R vector cross P vector, which we can also express as RP sine theta n cap or RMV sine theta n cap. Okay, now let us talk about these expressions in different ways. Okay, one by one I will tell you. Where L vector is equals to R vector cross P vector. Where R vector cross P vector we can write M into P vector, vector form, which is M into R vector cross. This is one expression. Okay, as I told you again, L is equals to RP sine theta n cap or L vector is equals to RMV sine theta n cap. Okay, these three basic expressions as of now we try to understand. Now let us try to discuss some more expressions based on this. So we clearly understood that angular momentum is a vector quantity because the result of cross product of two vectors is always a vector result. So the resultant direction of this L or the final direction of this L, how to determine and why it is R vector cross P vector, why not it will be P vector cross R vector. Okay, clearly it is very clearly it is saying that it is a cross product of two vectors. Then why we should consider only R cross P? Why not P cross R? For that also we have a reason. Let us discuss. First direction Bakula. Let's see the direction. Generally in rotational mechanics, remember this. Rotational mechanics. Clockwise direction is considered to be negative and anti-clockwise direction is considered to be positive direction. Generally plus z and minus z like that in that point. Now see, to this observer, this point mass is appearing like this, like going like this, where his position vector is keep on changing. Now if I say the cross product of R vector cross P vector at any instant from the situation, let's say somewhere here, point mass is there with a velocity this side, where this is the position vector of that particular instant. Let's say angle is theta. Now cross product of these two vectors will take because v direction is nothing but the p direction, because the linear momentum will be always directed along the direction of the velocity of the body. So now, if I want to apply the condition of r vector cross p vector, we always go with right hand thumb rule. What does it means? You take your right hand and keep the fingers in the direction of first vector and then rotate the fingers in the direction of second vector. That means R vector is like this. Look at the screen. R vector is like this and V vector is like this. So cross V. It appears to be into the plane, right? So appears to be into the plane actually means that, as I told you, clockwise, anti-clockwise. Clockwise, I mean like this. Into the plane. What is that? Minus z axis. Anti-clockwise like this. Anti-clockwise like this. So outside the plane, which is positive z axis. So here we can conclude that since the object is traveling like this to him, to the person, to the observer who is sitting at the center or origin, it appears like to rotate in a clockwise direction, which means the resultant of r vector cross p vector or r vector cross p vector will be or must be coming into the plane, because clockwise direction according to the rotational mechanics condition, what is it? Minus z axis. So it must appear like in anti-clockwise direction, clockwise direction. Okay, see, now look at the situation. When the instant started here, the theta was like this, and then object started going like this at one particular instant. Position vector will be changing like this, which means angle is appearing like this only, which means it is moving in clockwise side. So to satisfy this condition, I mean the condition of rotational mechanics, the condition of right hand thumb rule, like vector product of two vectors, both must be satisfied. Condition of rotational mechanics is what? When a particle is moving in clockwise direction, its direction is considered to be negative z or negative axis side. If I apply right hand thumb rule for these two vectors, it must satisfy that condition, which is only possible with R bar cross P bar. If I take P bar cross R bar, for example, what is the wrong with this condition? If you see now, P vector is like this, R vector is like this. So now apply P bar cross R bar. First vector, you can take second vector here also. See, first vector is like this, in this direction. Cross second vector like this only. So rotate the fingers like this. How it is appearing? Out of the plane. Out of the plane gives what condition? Plus z axis, which means it appears to be in anti-clockwise direction. But practically, in practical situation, if we see, to him it is appearing like what direction? Clockwise direction. To satisfy third condition and this condition, we always must take the cross product of r vector and p vector. If you take p vector cross r vector, it gives exactly opposite direction of the resultant. So r cross p is mathematically, according to the direction, is correct, not p cross r. But it is a cross product of position vector as well as linear momentum vector. Clear? Understand the direction condition and the cross product condition? Okay. Now see. Now see. Now see this situation. At any instant. Okay. Situation. Like this is at any instant, as I told you, position vector. At that instant, this is the velocity vector, which means p vector also we can consider, as I told you. Now, by using some vector rules, let us calculate some other different expressions of this angular momentum mathematically. See, isn't it? Now see, if I write this in two different ways, like this one only let us see. R M mass constant, let's take out R. If I take it as V sine theta, V sine theta separately I took. Or one more possibility, M into V, R sine theta separately. What does these two expressions actually means? Let us see. If I take the situation as at any instant, position vector, at that instant, velocity vector. This is R vector. This angle, let's say theta. This is x-axis and this is y-axis. Now, see the components of R. What will be our components? This component will be R cos theta, isn't it? And this component will be R sin theta, which means this is R sin theta, right? This is what R sin theta, right? Yes. Now, what if I take the components of V? Because this also will be theta. So this component will be V cos theta. This component will be V sin theta. Right? Now see. This expression I'll explain from the diagram. M and R. M is mass. R is the magnitude of the position, which means this length, which means this length. And V sin theta. What is V sin theta actually? V sin theta is the perpendicular component of velocity to whom? To R vector. What is the meaning of v sin theta here? Perpendicular component of the velocity, perpendicular component of the velocity to the position vector. That is what v sin theta. Like that, if you see this one, r sin theta is what? R sin theta is this distance only, no? Here only observer is there, right? When observer is here, this particle appears to rotate about this point. To him only it is appearing like it is rotating, which means this is said to be axis of rotation. Axis of rotation only, no. Now, what is r sin theta? Line of velocity if you plot. Line of velocity and axis of rotation between the 2 points or between the two cases, whatever the shortest distance is there, that is what? R sin theta. Which means we can write it is the perpendicular distance. Again, the perpendicular distance between what and what? Between line of velocity, between the line of velocity and axis of rotation. Perpendicular distance between line of velocity and axis of rotation. So the final conclusion, L vector's magnitude is M or V perpendicular. It's a perpendicular component, it's a perpendicular component, right? Or we can also write L magnitude as M V R M or V perpendicular or MV R perpendicular. V perpendicular means the perpendicular component of velocity to the position vector. R perpendicular means the perpendicular distance between line of velocity and the axis of rotation. Remember, any formula that we can use according to the given data in the question. There is no rule like we must use only this formula or that formula. From the starting of the angular momentum to the ending part of the angular momentum, whatever the formulas that we have discussed, all the formulas are applicable according to the given situation. But we need to pick the right formula for the right question. That only comes from the practice. Okay, so do not ask me that what formula to use according to the given condition. That you will come to know only when you practice more number of questions. Okay. Yes. Now, based on these all cases, let us discuss one question. Like for the very basic formula, let's discuss a question. And for this R perpendicular and B perpendicular, let's discuss let's discuss previous year questions based on the condition, models at least. Okay. See, very first question that I'm writing. If an object is moving with velocity v vector is equals to 2I cap plus 3j cap minus k cap. Then find its angular momentum. Its angular momentum about the origin when when it is at point 1 comma 1 comma XYZ பிளேன்ல தானே மூவ் ஆகுது. ஏதாவது ஒரு பாயிண்ட் 1 காமா 1 காமா 2 இருக்கும்போது ஆரிஜின்ல வச்சு பார்க்கும்போது இதோட ஆங்குலர் மொமெண்டம் எவ்வளவு இருக்கும்? Take the mass of the body as 2 kg. Did you understand the question? But தமிழ் சாரி தமிழ் எக்ஸ்பிளைன் பண்ணணும். அது அப்படியே ஃப்ளோவில் வந்து என்ன செய்யும். சரி, ஓகே. சி, velocity of the particle is given and the point at the instant we need to calculate the angular momentum also is given, and about the what point we need to calculate the angular momentum also is given. That means indirectly the given data is point P somewhere here which is 1 comma 1 comma 2. So that position vector we can take with respect to origin, and it is being observed from where? Origin, because I clearly mentioned that about the origin About the origin means what? When observer is observing from the origin, if it is appearing like rotating in a circular path or rotating in a rotational dynamics, what will be its angular momentum? That's the question. So I can say R vector is nothing but final position minus initial position only. No, that is nothing but I cap plus 2 I cap plus j cap j cap plus 2k cap minus 0 I cap plus 0 j cap plus 0 k cap. Originally, no. So which is nothing but I plus j plus 2k. This is our vector. And we know velocity vector is given to I plus 3j minus k. Then angular momentum will be what? R vector cross m into b vector. So m you can take out. What is this? R vector cross. Can you solve the cross product of the two vectors? Solve. Solve it and tell me the final answer. Cross product of the two vectors you have to calculate right now. 5j minus k multiplied by m is 0. Sorry. M is how much? 2. This is only r cross b. R cross b only know. So will be how much? Minus 14i plus 10j minus 2k. This unit is what? MVR. MVR na kg meter per second into again meter kg meter square per second. This is what. Okay. So cross product of two vectors conditions are very important. So briefly I'll explain. If A vector and B vector are there, so A cross B will be AB sine theta n cap. What is this? What does this n cap means? It means that the direction of AB sine theta is perpendicular to A vector as well as B vector. That is the meaning of this n cap, which means normal direction. Normal direction means perpendicular direction. So if I take A vector cross B vector is equals to C vector, remember A vector will be always perpendicular to C vector as well as A vector is so B vector is always perpendicular to C vector, which means A vector dot C vector is 0 and then B vector dot C vector also will be always equals to 0. So resultant of two vectors in a cross product will be always perpendicular to the two vector which got multiplied in cross product. Okay, very important condition. Okay, so this is one model of the question to calculate the angular momentum. Try one more question. This is very famous model question. Very important also. A projectile is thrown at an angle theta with horizontal. Okay, with velocity, with initial velocity u. Then find first question. Angular momentum about its point of projection when it is at its maximum height. Second question. Find angular momentum about the same about its point of projection when it is about to reach the ground. About to reach the ground. Okay. So if you plot the diagram, if you Draw the diagram of this projectile case. It looks like this. Initial velocity u, initial velocity u at an angle theta with horizontal, and when it is at highest point, when it is about to reach the ground, in the end points இருக்கும்போது, what is the angular momentum of this particular projectile about the origin or about the axis of rotation, which is at the point of projection. Take the mass of the projectile as m, mass of the body in projectile motion as m. Think of it. I'll give you 2 minutes time. Think. And the perpendicular distance, if I take, what is this perpendicular distance? Maximum height, then maximum height only know. Upon angular momentum, I can say that m v are perpendicular. M V is what? Velocity at that instant. What is that? R perpendicular is what? Maximum height. So L will be M into U cos theta into maximum height. Maximum height formula another. U square sine square theta by 2g. So the final answer will be M U cube by 2g into sine square theta into cos theta appears to be in clockwise sign, right? Because different positions, if you see, the theta is going like this, so clockwise direction, so minus k. Understand? Angular momentum of the projectile when it is at its highest point about the point of projection is this much. Can you try the second question at least? Try the second part of the question. Think of it when it is about to reach. Which formula will be suitable to solve it? Think and tell me. Try பண்ணணும் பார்த்தா வராது. If you see it won't. You have to try. Make it fast. When it is about to reach the ground, how velocity will be looking like? About the point of projection, what possibility is there to calculate the angular momentum? Think and try. So when it is about to reach the ground, this is the velocity direction. Now see, this is the axis of rotation. Two conditions that I can apply. Either take the line of velocity and find out the perpendicular distance between them and apply MVR perpendicular. Okay? Apply M because with what velocity it left from the ground, same velocity it will be reaching, velocity in the sense magnitude of velocity, it will be reaching the ground. Components will be just reversed in vertical direction. Horizontal component will be remain same. So either go with MVR perpendicular by calculating this distance. Because this distance we already know is nothing but range. MVR perpendicular. Velocity is nothing but initial velocity only. U. Okay. But it will be directed like this. Magnitude will be remain same. And R perpendicular is the perpendicular distance between line of action of velocity and the perpendicular distance from the point of projection or axis of rotation. This is one possible case. Or one more possible case is what? M R V perpendicular. M R V perpendicular. Na? R is this only, no position only, no. Perpendicular distance, it's not perpendicular distance. What is this R? This is the position at that instant. That means range only. So V perpendicular will be like this. If it is projected at an angle theta with horizontal, so with horizontal theta will be remain same. So then this will be, this is U actually, this will be U cos theta always. This will be what? U sine theta. Now, the perpendicular component of velocity to the position is u sine theta only. No? Understand my point or not? Either you go with first condition or go with second condition, but both must be giving the same answer, then only it is correct. So first I will check with the second condition. L I am taking as M or V perpendicular, where M R is what? Range. V perpendicular is what? U sine theta. So if I write it, M R is what? Range U square sine 2 theta by G into U sine theta, which is M by G into U square. Sine theta, sine 2 theta, we can write 2 sine theta into cos theta, upon 2 sine theta into sine theta, sine square theta into cos theta. So the final answer will be along with the direction, it will be 2mu square by G into sine square theta into cos theta minus k cap. Clockwise direction only, no, obviously, like previous case. Sine u cube, sorry, u cube. Okay, this is by one condition. Another condition, let's see, what is that? L is equals to magnitude only. M, V are perpendicular. Let us check what is the value of R perpendicular. V is u only. So now this length I need to calculate. As I discussed now, if I take this value as theta, okay, now this is line of action of velocity, then this will be theta, right? Isn't it? Opposite angles of the same two pair of lines. Okay, or this one, this and this. So this and this theta. Now, if it is theta, this is r, this is perpendicular point. What I can write r perpendicular by using this information? I want this value. I know this value as r. If I use sine theta is opposite by hypotenuse, right? So from the triangle, I can write sine theta is equals to opposite is r perpendicular by r. From this r perpendicular, what we will get? R sine theta. So now L value will be what? M into V is final velocity, which will be equals to initial velocity in magnitude U into R times sine theta. Again, you can write M U. R is what? U square. Sine 2 theta I am writing as 2 sine theta into cos theta by G into sine theta. What it will be? M U into U square. U cube into 2 by G. Sine into sine, sine square theta into cos theta. Clockwise direction minus k. Isn't it same? Yes. Both are same. So the conclusion of the story is, bro, whatever the formula that is convincible or easily applicable for the given situation can be used. There is no rule for it. And whatever the formula you use according to the given data and your comfort, the answer will be same if you do in a right way. If it is correct, the answer will be same, whatever the formula you follow. Whether you take MRV perpendicular or you take MVR perpendicular or you take R bar cross P bar or you take M into R bar cross V bar, whatever you take, whatever the formula you use, answer must be or answer will be same if you do in a right way. Okay, so different case but very important case. I hope you understand. Now let's go to next concept of this angular momentum, that is angular momentum of rigid bodies. Rigid bodies, and this is actually for point mass only. Now we discussed a point mass is traveling with a velocity v of mass m. That only we took. Now, if I take a rigid body, like distribution of mass is there, how to calculate the angular momentum of third rigid mass about any axis of rotation? Let us see. Derivation is not important, but the final result is very important. Based on that, we have many applications. So the condition will be like side heading you can keep as angular momentum of any rigid body. And I'm taking the case only for pure rotation. Very first starting of rotational mechanics, we discussed rotation is of two types. Pure rotation and impure rotation. Pure rotation axis of rotation fixed இருக்கும். Impure rotation axis of rotation also will be moving. That is called as rolling motion. Rolling motion வரும்போது we'll talk about the angular momentum of the body in a rolling motion. That is a separate case. Now we are only going to discuss about a rigid body is in pure rotation. Then what will be its angular momentum? Okay. So let's take a situation. Let a beautiful rigid body is there like this, like our half boil. Huh? Ah, sorry. Record also no. They don't know. No, those will see. Okay, see. Now let's take axis of rotation here. Okay, this is my axis of rotation of the body. Let's take its rotating in anti-clockwise direction. Now I want the angular momentum of this rigid body. Very simple logic I'll apply as I'll take any point mass somewhere here, dm, where total mass is m. That dm's angular momentum I'll calculate and then I'll integrate the value from the starting to ending limit. So this point mass angular momentum dl, what it will be? Point mass in rotation, what it will be? M into V into R perpendicular I can write. R I can use M into R into V perpendicular. Anything where M is dm, where M is dm, point mass is dm. So I'll take this because this will be in a circular path only. So that will be clearly having R perpendicular as nothing but radius. Let's take radius as any x. Okay, any x. Now if I take this dm into v. So it is rotating with angular velocity omega, then its linear velocity will be what? X omega. V is equals to R omega only, no? X omega because the radius is x. Into R perpendicular is what? X. Then what it is? Dm into omega into x square. Now angular momentum will be what? Integral of dm into x square into omega. In this x is variable, obviously, if I take point mass at different positions, x value will be changing. So I'll keep it like this. Omega into this part separately as integral of dm into x square. Is it like known formula somewhere we have seen this formula? What is dm into x square? Array dm into x square is nothing but moment of inertia, right? Mass into perpendicular distance square. So this is nothing but omega into integral of di because dm is there. So integral of di will be what? I. So what it will be? Angular momentum of any rigid body is nothing but I omega. Maybe clockwise or anti-clockwise, plus or minus k. I omega. So very important conclusion, bro. That is angular momentum of any rigid body whose moment of inertia is I is given by I omega. If it is in pure rotation, axis of rotation இருந்து பார்க்கும்போது again when you are seeing from the axis of rotation in pure rotation, the angular momentum of a rigid body is given by I times omega, where I is the moment of inertia of the rigid body about axis of rotation. And what is omega? Angular velocity. Sorry, that is velocity. Okay, clear? Now see example. For this example, tell me, you have to say the answer. If I take a disk or if I take a solid sphere, this is SS. SS, no, it's not SS Rajamouli, it is solid sphere and it is disk of mass m, radius r. Mass m, radius r. Is rotating about its own axis. இதுக்கு own axis இருக்காது, இதுக்கு தான் own axis. Tell me what is the angular momentum. Tell me what is the angular momentum. Tell me what is the moment of inertia of disk about its own axis. If it is rotating with angular velocity omega, enago. What about this? 2 by 5 Mars square into its angular velocity omega if it is rotating with omega. Got it? So whenever rigid bodies are given in pure rotation, the angular momentum is simply considered to be I omega. L is equals to I omega. Now, axis of rotation is at any other different places. How to calculate angular momentum? Let's see in another example. Now take the situation. Three spheres, three spheres, solid spheres will be of mass m and radius r are placed at the vertices of an equilateral triangle of side length. Okay, and now this system is rotating about an axis passing through one of the centers of the spheres with omega. Now, what is the angular momentum of this system? Okay, this is also m and r, m and r. All three are identical. Tell me. Paak kuda the answer solunum pannittu. You complete it and tell me the answer. That's here. Center of mass எதுக்கிட்ட calculate பண்றீங்க? L is equals to I of the system into omega only. You know what is the moment of inertia of the system? Moment of inertia of this sphere is 2 by 5 mr square. Moment of inertia of this sphere about this axis 2 by 5 mr square. But this is not the axis, so this is the axis that I need to consider, which means parallel axis theorem is to be applied. Plus m into what is this distance? A by 2 whole square upon a square by 4. The moment of inertia of this about this axis we know 2 by 5 mr square. But I want about this axis. What is the condition? Parallel axis theorem. M into what is the distance? A square. The total moment of inertia will be 2 by 5 mr square, 2 by 5 mr square, 2 by 5 mr square. How many times? 3 times of 2 by 5 mr square plus ma square by 4 plus ma square. Okay, so now it will be 6 by 5 mr square plus m by 4 a square plus m a square into omega. Moment of inertia into omega only no. So you take any common points are there. M can be common out. Okay, let it be. Why to take m alone? This is the answer. I omega. Moment of inertia of a angular momentum of any rigid body is moment of inertia times into omega. Understand? So total four conditions that we discussed today fully. Point mass case three conditions are there for angular momentum, and for rigid body one condition is there, which is I. Okay or no? Now write one more question. Try. Find the angular momentum of a rod of mass m, length L, if it is rotating about one of its ends with angular velocity omega. Tell me, what is the angular momentum of this rod? Rod of mass m, length L is rotating about one of its ends. Then what is the angular momentum of that? Angular velocity is given as omega. ml square by 3 ml square by 12 ml square by 3 into okay. One more question. Find the angular momentum of a system of a disk of mass m and a point mass attached to it at the edge of mass small m. You can take capital M is equals to 3m in the continuous pala. Radius r. About its own axis it is rotating. Own, about its own axis it is rotating. So its angular momentum about its own axis. With angular velocity omega it's rotating. Tell me. 1 minute only. A disk and a point mass m attached to edge are rotating about its own axis of the disk, then what is the angular momentum? 4 mr square into omega. How? 3 mr square எப்படி வரும்? Disk mr square. What is the moment of inertia of disk? So I of disk plus I of point mass into omega, isn't it? Total moment of inertia of the given system times omega. So disk moment of inertia is 3m into r square by 2 plus point mass is on edge. So from here it appears to rotate like this, which means the distance of axis of rotation is r. So I will be m r square into omega. Then what it will be? 5, I only know, by 2 m r square into, got it? Okay, so this is the way that you need to apply angular momentum calculation part for any point mass system or rigid body. Okay, so I hope angular momentum for pure rotation part has completed. Actually, after this, still angular momentum will come back once we complete torque, because there are concepts related to torque and angular momentum again, and angular momentum regarding the impure rotation, like rolling motion is there. That will be very nice concept. Like no advanced level we can go up to advanced level, because it will be very like deeper concepts of the rotational mechanics. One of the deepest concept of rotational mechanics we'll see after completing torque, because to understand those concepts first you must know what is torque and how to calculate torque. Okay, so next class will be on torque for a point mass system as well as rigid body. Once we complete the torque, we can again combine angular momentum and torque in a one single concept, and we can discuss some more applications. And then at last we can go with rolling motion. Rolling motion will be the last topic of the lesson. Okay,